In this problem, we are being asked to use Bayes' theorem to calculate a conditional probability. So you see this notation here. This means the probability of A given that B is true. And that's what Bayes' theorem does. It calculates these conditional probabilities. If B is true, what's the probability of A? To calculate this, you need a few things here. You need the probability of A, you need the probability of B, and you need this tricky bit, the probability of B given that A is true. So if you can get all of those things out of the data that you have, you can go ahead and use Bayes' theorem. This gets a little bit confusing, especially the first few times you're doing it. So I think the best thing to do is to list all the things we need. So we need the probability of A, we need the probability of B, and we need the probability of B given A to calculate this probability of A given B. But we also need to figure out what these things actually mean in the context. Let's just read this problem first and see if we can sort this out. It says a class of 40 students has 12 honor students and 11 athletes. 3 of the honor students are also athletes. 1 student is chosen at random. Find the probability that the student is an athlete if it is known that a student is not an honor student. Okay, so we want to find the probability of being an athlete if the student is not an honor student. What that means is that A is athlete and B is not honor student. So let's find the probability of A first. Probability that a student in this group is an athlete. It says the class has 40 students and 11 are athletes, so that's pretty straightforward. 11 out of 40 students are athletes. Now B's a little bit trickier. We're told how many honor students there are, but we have to remember we want not honor students. So we'll just have to subtract. If there are 12 out of 40 who are honor students, that would leave the others 28 out of 40 who are not honor students. Now the trickiest bit is here, the probability of not being an honor student, that's what we've decided B is, given that they're athletes. So again, we're going to have a fraction with a top and bottom, and this part, the given part, is going to tell you what goes on the bottom. There are a total of 11 athletes, so if you're given that you're an athlete, that's the group we're choosing from. So I'm going to put 11 on the bottom. And we just need to figure out how many of those are not honor students in the athlete group. We're told here that 3 of the honor students are also athletes, so that means 3 of the athletes are also honor students. Those who are not honor students would be those that are left, so we subtract again from 11, we get 8. Okay, so we've got all the probabilities we need, we just need to plug them in this formula. So first, probability of not honor student given that someone's an athlete is 8 out of 11. The probability of being an athlete in this group is 11 out of 40, so we multiply those two together, and then we put them over the probability of not being an honor student, and that's 28 out of 40. All right, so you can see we've got some fractions here, complex fractions. What I want to do is make the denominators the same. The denominator here is 11 times 40, so I'm just going to multiply this one by 11 over 11. Then the denominators are the same. Now if you do that, you can think about, actually let me just rewrite this. So I've got 8 times 11 on the top of this fraction and 11 times 40 on the bottom. And that's over 28 times 11 on the top and 40 times 11 on the bottom. Those are the same. So if I multiply this whole big fraction by 11 times 40 over 11 times 40, this cancels with this cancels with this. I just get, let me move over here, 8 times 11 over 28 times 11. And look at this, the 11s cancel. I get 8 over 28, and we can divide both those by 4, and I get 2/7. So that's simplified quite nicely. So the probability of being an athlete, if you're not an honor student, if it's given that you're not an honor student, is 2/7. We're going to do a couple more problems like this, but I'm going to put them in separate videos, so stay tuned.